Hi students, in our previous video we had discussed about thermal decomposition reactions. That is, when the lead nitrate is heated, what are the products we are getting, and also when ferrous sulfate is heated, what products we got, and when calcium carbonate was heated, what products we got, we had discussed. There we had already discussed. When a single reactant decomposes to give two or more products, it is called as a decomposition reaction. Then we explained that we had heated by the help of any gas, and those reactions we call as the thermal decomposition reactions. Those decomposition reactions are under the types of chemical reactions. In this present session, we are seeing the second kind of decomposition reaction. Means when we decompose any reactant in the presence of electrical field. That may be a direct electrical source or using a battery. Those types of decomposition reactions that are taking place in the presence of any electrical field, they are called as the electrical decomposition reactions. Very good. Now we are having one activity and a very important diagrammatic question for the electrical decomposition reaction. At times in the board examinations, they will ask you the diagram of the electrical decomposition reaction. So let us see how we are doing this electrical decomposition reaction. So for this, we had a lot to study first. Before we go on studying a lot, we will note down each point wise what we need to choose first. First of all, you choose a mug that we have in the day-to-day life. That is what I have taken one plastic mug. So first thing is, take a plastic mug. After taking the plastic mug, at the bottom make two holes. Make two holes at the bottom of the mug. After making two holes here, you please insert electrodes. The electrodes are made up of carbon, so they are called as the graphite electrodes. Means after placing the hole, we will insert two electrodes in them. So make two holes at the bottom of the mug and insert two electrodes in them. Two electrodes in them. So first we will be placing the electrodes. Then one of the electrode is connected with a wire to a switch. Another electrode is connected with the help of a wire to the cathodic end of the battery, 6-volt battery. This wire of anode we connect for anode of the battery. So the wires that are coming from one electrode we connect to the anode, and the another end we connect to the cathode. But in between we take the help of a switch to start and stop the flow of current. Now, after doing this entire setup, you take the water in the mug. What to take in the mug? Take water in the mug. So first thing, connect anode and cathode to the terminals of battery. To the terminals of battery using a switch. to the power switch where connect the terminals of the battery. Then you please take the so-called content number what we need to add. We are not adding much, we are adding very simple content that is called water up to the half, such that the electrodes will be immersed in that. So add water into the mud until the electrodes were immersed. Add water into the mud until electrodes were immersed. Immersed means until the electrodes were covered. Then you place or you take two test tubes. What are we going to take? Two test tubes. One of the test tube, you place it on one of the electrode so that the water will pass into the test tube, and the another test tube you insert over the second electrode in the inverted form. We are inverting the test tubes over the electrodes that are present on the both anode and cathode. Place two test tubes over the two electrodes. Over the two electrodes. Don't forget, after this adding the water only, we have placed the two test tubes over the electrodes. Means now the water is present in the electrodes also. Our concept is to discuss the electrical decomposition reaction, which is going to undergo decomposition. Means the water is going to undergo the decomposition reaction. How is it going to undergo the decomposition reaction? The water, H2O being the formula, when it is undergoing the decomposition, electrical decomposition, it will give hydrogen gas and the oxygen gas. What are the products here, children? Hydrogen gas and the oxygen gas. See, we have only 1 mole of reactant, but in the product we got 2 moles of oxygen. To balance that, we are taking 2. So when we undergo or do 2 moles of water, we are going to get 2 moles of hydrogen gas and 1 mole of oxygen gas. This number indicates the number of moles. So how many moles of hydrogen gas we got? 2 moles, whereas only 1 mole of oxygen gas. Means at anode and cathode, we don't know which gases were formed. Here we label this as oxygen gas, here we label this one as hydrogen gas. How to understand this gas which is generated at the electrode? You please observe, in one of the electrode, this is only very less amount of gas developed, whereas in another electrode, another test tube, we got more amount of gas. See the equation, which gas is more, hydrogen gas or oxygen gas? We can find 2 moles of hydrogen gas and only 1 mole of oxygen gas. Means the one there which we have more amount of gas collected, it is hydrogen gas, and the one that is having less amount of gas collected, it is called as the oxygen gas. So this is the confirmation just to say why there is more gas in one test tube than in another test tube. This is to say, account the chemical reaction, when 2 moles of water decomposes, they give 2 moles of hydrogen gas, only 1 mole of oxygen gas. So this is what we say during an electrical decomposition reaction. A single reactant is decomposing to give 2 products in the presence of electrical field. That is the balanced equation. For the examination point of view, we need to have this diagram to be practiced. And one main important question is, among oxygen gas and hydrogen gas, how to know this is the oxygen or hydrogen? We have a confirmatory test for hydrogen gas. What do we have? A confirmatory test for hydrogen gas. Let us see the confirmatory test for hydrogen gas. So let us see the confirmatory test for hydrogen gas. Question is, how do you confirm hydrogen gas? How to confirm the hydrogen gas? In any of the test tube, some gas was there. We don't know what gas that is. Then we can imagine that the test tube is having some hydrogen gas for our imagination purpose. When we brought a burning matchstick near to the mouth of the test tube, we will burn a matchstick and bring it near the mouth of the test tube. This burning matchstick will blow off, giving a pop sound. The burning matchstick will blow off, giving a pop sound. So the matchstick will blow off, giving a pop sound, because this hydrogen gas had catched the fire and it had blown off. Since hydrogen gas is having the property to be combustible, so it is used as rocket fuel in the rockets. The rocket fuel is nothing but hydrogen gas in one container and oxygen gas in another container. So that is the rocket fuel. This hydrogen gas is highly combustible. So what do we say? Hydrogen gas is highly combustible. If they ask how do you confirm hydrogen gas, we write the definition. When a burning matchstick is brought near the mouth of the test tube, it blows off with a pop sound. Which will blow off with a pop sound? Burning matchstick will blow off with a pop sound. Very important point. This is the confirmatory test for hydrogen gas. Let us see the third kind of decomposition reactions. Up to now, we had discussed thermal decomposition reaction and also the electrical decomposition reaction, and now we are going into the third one, the decomposition reaction that is going to take place in the sunlight. The decomposition reaction that is going to take place in the presence of sunlight, we are going to call them as the photoelectric decomposition reactions. What are we going to call them as the photoelectric? Photo, they will give, sunlight is going to give photons. So it is called as the photoelectric decomposition reactions. So the definition you can see, decomposition reactions that takes place in the presence of sunlight were known as photoelectric decomposition reactions. For this, what the things do we want? We want a very simple things. We are going to take a china dish. Again, don't think the china means it is going to get corona in the dish. This china dish is made up of porcelain, and in the starting days, first it was developed in the China, so this is called as the china dish. Even we can take a watch glass also. In that, we are going to take a compound called silver chloride. What is the compound we are going to take? Silver chloride. And we are going to place this entire china dish cup containing silver chloride in the presence of sunlight. In the presence of sunlight. The silver chloride formula one in which single reactant decomposes to give two or more products. Here Ag is formed and chlorine will be escaping in the form of the chlorine gas. At the end of the reaction, what are the products means? Metallic grey color silver. Metallic grey color silver. And chlorine gas that is going to be escaped from the container. But let us see, there is one silver, there are two chlorines. So let us make a question number 2, that is going to say 2 moles of silver. So 2 moles of silver chloride are taking them on a China dish and placing under sunlight, they are decomposing to give a grey color compound. What is the color of the compound we are getting? Grey color compound. Here initially it is white in color. What is the compound color? White in color. At the end, the change in colors when we want to study, the white colored silver chloride changes to grey colored metallic silver and chlorine gas. So in this activity, what is the application? Nowadays everyone is having a camera with them or the phone in which they take the photos and they can directly have a color print. But in the olden days, once they take a photo, the photo used to be loaded in a reel. That reel they used to develop by placing some content in a container, liquid. That liquid they used to apply there the silver chloride or silver bromide. And those days they used to develop only black and white photos. So those days they used to apply this phenomena. That is, they used to place the negative in a solution and it used to develop one color and they used to hang in the presence of sunlight. There the color used to be developed. So the application is, this is used in black and white photography. Which is used in black and white photography? The decomposition reaction, photoelectric decomposition reaction of silver chloride is applied in the black and white photography. Not only that, you can take even silver bromide. Silver bromide. Even the silver bromide, when placed in the same China dish and placed under sunlight, the products what we find are 2 moles of Ag plus bromine gas. Here also we can find the grey colored compound that is formed from the white colored compound. So what is the common thing here? Silver is the common. Here we got chlorine, there we got silver. Sorry, bromine. The only difference is with the halogen. So the decomposition reactions that are taking place in the presence of sunlight, we call them as the photoelectric decomposition reactions. Decomposition of silver chloride and silver bromide are the 2 examples. Up to now we have discussed only the 3 kinds of decomposition reactions. So under the types of chemical reactions, we have discussed the combination reaction, we have discussed the decomposition reaction. Let us go for the third one, the displacement reactions. The third one is going to be the displacement reactions. So the third kind of chemical reactions is the displacement reactions. Before we go into the displacement reactions, let us have a small question around. Can you could say the metal that is not at all reactive? Now you may have a question. What is meant by the meaning the metal that is not at all reactive? Okay. Maybe at your home, your mother, your sister, if you are a girl, you will be wearing which one? Iron or gold? Why don't you wear iron? Here you prefer gold because that is costly. That's what you will be using. You can use even platinum also. But what happens if we wear iron? The point is the gold or platinum, they will not react with any atmospheric gases and they will not develop any rust on them. Means they will not undergo the process of corrosion. Corrosion is the process in which a metal reacts with atmospheric gases. But silver will be forming a black color when left in air, but that is after living for many months. But the gold will not react with any atmospheric gases. Platinum will not react with any atmospheric gases. Means they are not at all reactive with atmospheric gases. So we call them as the least reactive metals with atmospheric gases. If you come across the point, then what is the metal that is highly reactive with atmospheric gases or even with water? You take a small cup of water. In that you place a small piece of potassium or sodium. Immediately they will catch fire. Generally water is used to blow out the fire. But when you place potassium or sodium in a cup of water, it will start firing. It will generate some fire around it. Means they are releasing hydrogen gas when reacting with water. Which are reacting? Potassium metal or sodium metal. We speak they are highly reactive metals. What are they? Highly reactive metals. So based on the reactivity of the metals, we got a chart, metal reactive series. What is the chart we call? Metal reactive series. In this chart, we got the metals from the highly reactive to the least reactive. Let us see what is this chart. Highly reactive are potassium, sodium. Then it goes on like calcium, magnesium, aluminum, zinc, iron, lead, hydrogen. Your question will be, why hydrogen was taken here? It is not a metal now. It is taken as a reference. Means the above metals are reactive more than hydrogens. Below metals are reactivity less than hydrogen. These can displace hydrogen. These can displace hydrogen. But these cannot displace hydrogen. We will understand again. Followed by copper, mercury, silver and gold. So this metal reactive series is from top to bottom. It shows that this is the decreasing reactivity in series. Or we say the top are highly reactive. So once we know about this metal reactive series, then we can clearly understand the displacement reaction. Means we can study lead and iron if you take, which is highly reactive. Iron is highly reactive. If you take iron and zinc, which is highly reactive, zinc is highly reactive than iron. Among zinc and aluminum, which is highly reactive, aluminum is highly reactive than zinc. Among magnesium and aluminum, which is highly reactive, magnesium is highly reactive than aluminum. So you can say now, among all the metals in the given list, potassium is highly reactive than any of the metal. So it can readily react with water for giving or it catches fire. So please take a snapshot, children, of the metal reactive series. This is much helpful for the next session, displacement reactions. Thank you.